This is the human brain, the most complex structure in the universe. It controls every thought, movement, and heartbeat you have. But sometimes, cells grow out of control. A tumor forms. As it expands, it crushes. The skull is a closed box. There is no room for extra growth. Before touching the patient, surgeons use MRI scans to create a 3D GPS map. This precision is key. The patient's head is secured in a Mayfield clamp. If the patient moves even a fraction of an inch, the surgery could fail. First, a curved incision is made in the scalp. The skin flap is carefully folded back to reveal the cranium, the hard bone armor protecting the brain. We cannot just saw through the bone, or we might hit the brain. Instead, the surgeon drills small safety holes called a specialized saw called a craniotomy is used. It has a footplate that slides under the bone to protect the brain, while the blade cuts the skull above. The cut section, known as the bone flap, is gently lifted off. We don't throw this away. It is preserved to be put back later. Beneath the bone lies the dura mater, a tough, leather-like sac that holds the brain fluid. This is the final.
The brain is now exposed. It pulsates with every heartbeat. This is the cortex.
The structures here are microscopic. The surgeon brings in a high-powered operating microscope to magnify the view 10 times.
The challenge is distinguishing the tumor from the brain. The tumor often looks different.
We don't cut the tumor out with a knife. We use an ultrasonic aspirator. This device vibrates at high frequency to liquefy the tumor cells. The process is called debulking. We hollow out the center of the tumor first, causing the outer walls to collapse inward, away from the healthy brain. With the center debulked, we carefully peel the outer shell of the tumor away from the healthy brain tissue. We follow the natural plane of separation.
Critical blood vessels often stick to the tumor. We cannot cut them, or the patient could suffer a stroke. They must be painstakingly separated.
To be safe, we use an electrical probe to stimulate the brain.
Bleeding is controlled using bipolar forceps. A tiny electric current seals the blood vessels instantly, keeping the surgical field clear. The tumor is completely removed. What remains is a resection cavity. The pressure on the brain, we must seal the barrier. The dura mater is stitched closed to be completely watertight. This prevents cerebrospinal. The bone flap is returned to its original position. It is secured with tiny titanium plates and screws. Finally, the scalp is closed. We typically use surgical staples for speed and strength. The wound heals quickly.
Anesthesia is reversed. As the patient wakes, the team performs an immediate neurological check.
Squeeze my hand.
Wiggle your toes.
Success.
The patient spends a night in the ICU for close monitoring. Astonishingly, many brain surgery patients.
The biggest threat is infection, specifically meningitis. Bacteria entering the brain fluid can be fatal. Sometimes, bleeding occurs after the skull is closed. This is a hematoma. It acts like a new tumor. The surgical scar can irritate the brain's electrical system, triggering seizures. Patients often take.
The brain reacts to surgery by swelling. This is edema. It can cause temporary confusion or weakness.
But the brain is resilient. Through neuroplasticity, it can rewire itself. If one area is damaged, surgery removes the mass, but microscopic cells often remain. Focused radiation therapy is used to target and destroy these invisible remnants.
Chemotherapy may also be needed. These powerful drugs circulate through the blood, hunting down fast-dividing cancer cells anywhere in the body.
Recovery is a marathon, not a sprint. But with modern techniques, thousands of patients return to.
The human brain is the masterpiece of biology. Fragile, yet incredibly strong. If you learned something new, hit the like button. Comment below. What surgery should we explain next? Heart transplant or knee replacement? See you soon.